Hello everyone, my name is Kekli Hadziyeva. I'm studying Baku University and my specialty Math and Informatics teacher. Today we'll learn Newton's laws. Let's start. I share screen, presentation. Okay, Newton's laws. Isaac Newton. So we're talking about Isaac Newton. Sir Isaac Newton, born 1643, and Sir Isaac Newton, an English scientist and mathematician, famous for his discovery of the law of gravity, also discovered the three laws of motion. He published them in this book, Physiology National Principia Mathematica, in 1687. Today, these laws are known as Newton's laws of motion and describe the motion of all objects on the scale we experience in our everyday lives. If I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. Sir Isaac Newton. Newton's law. First law, an object in motion tends to stay in motion, and an object at rest tends to stay at rest unless acted upon by an unbalanced force. We see first photo, and we see circle. So we talk about Newton's first law. What does Newton's first law formula? Basically, an object will keep doing what it was doing unless acted on by an balanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of any object. So, look at the photo. Two teams are playing tug of war. They are both exerting equal force on the rope in opposite direction. This balanced force results in no change motion. Look at the second photo. A soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. This example from real life. Newton's first laws, also called the laws of inertia. What is inertia? The tendency of an object to resist change in its state of motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has. Also, and the harder it is to change its motion. So, some example from real life. This is locomotive. A powerful locomotive being to pull a long line of boxcars that we were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia and it takes a large force to change their motion. Once they are moving, it takes a large force to stop them. So look at the second photo. This is butterflies. On your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia and exert a very small force on your car. If objects in motion can stay in motion, why don't moving objects keep moving forward? Things don't keep moving forward because there is almost always an unbalanced force action upon it. So look at photo. This is book. Um, um, a book sliding across a table slow down and stops because of the force of fraction. So look at second photo. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. So look at third photo. In outer space, away from gravity and any source of fraction, a rocket ship launched with a certain speed and direction would keep going in that same direction and at that same speed forever. So Newton's second law. Newton's second law, force equals mass times acceleration. F equal to m times a. So acceleration, what's acceleration? A measurement of how quickly an object is changing its speed. If you increasing the mass, you increasing the force. If you increasing the acceleration, you increasing the force. If you decreasing the mass or acceleration, you decreasing the force. Look at photo. Sometimes very small, low mass that's changed speed very quickly. Like a bullet can still have a great force. Something very small changing speed very slowly will have a very weak force. Second photo. Something very massive, high mass, that's changing speed very slowly, low acceleration, like a glacier, can still have a great force. So we look at formula, force equal to mass times acceleration. What does it mean? Force is directly proportional to mass and acceleration. Image a ball of the certain mass moving at a certain acceleration. This ball has a certain force. Now image we make the ball twice as big, but keep the acceleration constant. F equal to m times a says that this new ball has twice the force of the old ball. Now image the original ball moving at twice the original acceleration. Force equal to mass times acceleration says that the ball will again have twice the force of the ball at the original acceleration. We talk about 1 minute. We talk about this photo. Before ball constant, so after ball moving. So Newton's third law. For every action, there is an equal and opposite reaction. For every force action on an object, there is an equal force action in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you aren't moving. There is a balanced force action on you and gravity pulling down, your seat pushing up. Look at photo we talk about. Yeah, look at this photo. In this photo, what happens? If you are standing on a skateboard or a slipper pool and push against a wall, what happens? You slide in the opposite direction away from the wall because you pushed on the wall, but the wall pushed back on you with equal and opposite force. Second photo. Why does it hurt so much when you stop your toe? When you toe exert a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe hurts. Lesson is the end. Thanks for watching. Thanks for listening. Bye bye.